Okay, the first problem here says, what do you think the first and third figures will look like? So we don't have any information on first and third, but we do know the second and the fourth. So it says, what do you think the first and third figures will look like? And then describe the 10th figure. So why don't you just see if you can answer number 1. What do you think the first and third will look like, based on knowing the second and the fourth? Anybody have an idea on the first one? Jonas?
I think it's gotta just be like half of figure 2.
So basically one of those sides.
Yeah.
Okay. And you could draw it. Make a little note that means there would be 2 blue and 3 orange. Okay, so this one has basically 2 of those segments. This one has 4 of those segments. What do you think figure 3 will have? 3 of those segments, right? And again, you can attempt to draw that if you'd like. So it'd be 2 blue on top, 2 blue on the bottom, 2 blue on top, 3 oranges. Probably should darken it a little bit so you can tell. 3 oranges of all of them. So that one would have 9 oranges and 6 blues. Okay, so each one of these little segments, 1 of those in figure 1, 2 of those in figure 2, 3 segments in figure 3, 4 of those segments in figure 4. So what do you think figure 10 will look like? 10 of those segments. 10 of those little chunks. How many blue would you have?
20.
Okay, so figure 1 has 2 blues, and I'm going to 10, so I take that number times 10. 2 times 10 is 20 blues. How many oranges? Start with 3. Take it times 10 segments. It'd be 30 orange segments. All right, moving on to question 2. Okay, complete each of the tables. So what is my constant of proportionality for the first table? What am I taking everything on the left times? 100, right? So this side is times 100. So what is 0.94 times 100? 94. Move the decimal 2 spots to the right. 1.67 times 100. 167. Again, just move the decimal 2 spots. 57.24 Boston, what do you think?
5,784.
Move the decimal 2 spots to the right. 57.24. Brody with the X. 100. X. Might as well fill out the other one as well. How do I get from the left side to the right here? Divide by 100. Or times 1 over 100. So 250 divided by 100. Kaylee? What's that? 2.5? Yep. Do I need a 0 at the end? No, you don't. Wouldn't be wrong if you put it in there. 78.2 divided by 100. Faith, what do you think on that one?
0.782.
Yeah, move the decimal 2 spots left. 0.782. 123.9, decimal 2 spots to the left. Connor?
1. So 1 and 239,000.
Yep. 1.239 or 1 and 239 thousandths is correct. And next to the y. Kellen.
1 over 100 y.
Okay. 100th y, or y divided by 100. Either one of those would be fine. You could also label it as a decimal. Those all three mean the same thing. All right, so number 1, you can check that one off. We already completed the tables. For each table, find the constant of proportionality. Remember, that means the number next to the 1 on both of them. This one should be easy. You should be able to see the number next to the 1. 100. Right there. And what would be the number next to the 1 here?
1 over 100.
1 over 100? 100th, right? We got to divide by 100. 1 divided by 100 is 100th. And I like to write them as fractions. Why? Because I can see they are reciprocals of each other. All right, question 3. Well, I kind of just answered this one for you. What are the relationships between 100 and 1 over 100? Reciprocals. They are reciprocals of each other. For each table, write an equation for the proportional relationship. Let x represent the measured length. So length is my x. And y is in the length in centimeters. So these would be my y's. All right, so remember when we write an equation, we start with whatever's in the second column. What variable did it tell me to use for this column? It said to use y, right? So I'm going to start this one with y equals. Y equals 100 times x. Remember, the coefficient of the number should come first. Okay, how's that going to change for this one? Well, what letter represents the second column now? What letter represents length in meters? X. Equals. And what do I have for my equation? 1 over 100 y. So, a couple things I want to point out. These equations are really close to each other, right? You can always use or write two different equations. This one is usually the most common, y equals. Now if I look at this, what happened to my letters for me to make this equation? Okay, the letters switch. And what happened to my coefficient? What happened to my constant proportionality? All right, so if you ever have one equation, the easy thing to do to make the other one, I'll even write it down for you. 2 rules. To write second equation. Okay, rules to write the second equation. Rule number 1, flip variables. So I switch the order the x and y are. And then I'm going to write use reciprocal. Flip variables, use reciprocal. All right, so the are you ready? We'll look at that one, bottom page 40. How many cubic centimeters are in a cubic meter? Okay, so if I have a cube, and I'm going to convert it from meters to centimeters. So 1 meter, 1 meter, 1 meter. And I'm going to make it into centimeters. Well, how many centimeters would equal 1 meter on the bottom? 100. How many centimeters would equal 1 meter on the side? 100. How many centimeters would equal 1 meter high? 100. So how many times bigger is that? Remember when we did area, we took 100 times 100, right? Now it's cube. How many times do you think you have to multiply it? What's cube mean? 3, right? So you got to multiply it 3 times. 100 times 100 times 100. So that's going to be 1 with how many zeros behind it? 2, 4, 6 zeros. 1, 2, 3. 1, 2, 3. Okay, there are a million cubic centimeters in 1 cubic meter. So if you had a box that was, think of a meter stick, a meter by a meter by a meter, there'd be 1,000 little cubes that are centimeters that could fit in there. Sorry, a million little cubes that would fit in there. All right, how do you convert cubic centimeters to cubic meters? So we're going from something small to big. So that one you would have to multiply by 1 millionth. We'd multiply by the reciprocal of the answer you just found. How do you convert the other way? So what's the reciprocal of 1 millionth? Just multiply by 1,000,000. All right, question 3, page 41. Priya took 5 minutes to fill a water cooler with 8 gallons of water from a faucet that was flowing at a steady rate. Let W be the gallons of water in the cooler after T minutes. Okay? So W equals number of gallons after T minutes. So I know I'm going to have 2 equations. W equals and T equals. So you can go ahead and start with that. And then it gives me 2 numbers. I have 8 gallons and I have 5 minutes. So there's obviously 2 ways I can write that. I can write 8 gallons over 5 minutes. If I divide it out, it'll give me gallons per minute. Or I could write it the other way, reciprocal it. 5 minutes over 8 gallons. And that'll give me minutes per gallon. So what is 8 divided by 5? It looks like I have all decimals here. So I'm either going to get 1.6 or 0.625. So 8 divided by 5 is what? Anybody agree with that? Okay. So 1.6. So if I take that times my time, it tells me to use T for time. So it's going 1.6 gallons per minute for a half hour. You'd be able to figure out how much water came out of there. So there's equation 1. You see that one listed?
Yeah.
Yes. Which one? A. All right, so remember from what we just learned, let's say I wrote it as a fraction. How would I get my other equation? You remember the rules from the previous page? You flip the variables, and you use the reciprocal. Instead of 8 over 5, it's going to be 5 over 8. And which decimal do you think that one's going to be? It's got to be 0.625 if I would divide it out. So is it B or is it D? D, because it's T equals. All right, what does 1.6 tell you in this equation? We kind of already talked about it. What was my label here, remember? That's how many gallons of water per minute. What does 0.625 tell you? Remember, it's the opposite. Instead of gallons per minute, it's going to be minutes per gallon. Just flipping the order of it. Priya changed the rate at which water flowed through the faucet. Write an equation that represents the relationship of W and T when it takes 3 minutes to fill a cooler with 1 gallon of water. Okay. W equals how many? 3 minutes, 1 gallon of water. How many gallons per minute would you get? Which number is gallons? 1. Which number represents minutes? 3. All right, 1 gallon, 3 minutes, 1 over 3. What letter do I put behind it? T. Okay. Does this say write one equation? Let's say we're going to write the other one. Connor, what do I do with my letters? Flip them. Jada, what do I do with my fraction? Reciprocal. What's the reciprocal of 1 over 3? 3 over 1. And you don't need the 1 underneath. You can just write it like that. So either one of those equations is fine. Okay, was the cooler filling faster before or after Priya changed water? Okay, so at the beginning here, it was 1.6 gallons per minute. Now we're doing 1/3 of a gallon per minute. So was it faster before or after she changed it? Before. Explain how you know 1.6 is greater than 1/3. So she went from 1.6 gallons per minute to 0.3 gallons per minute. All right, question 4, page 42. At an aquarium, you're feeding a shrimp 1/5 of a gram. Think of a gram as like the weight of a paperclip, so 1/5 of a gram is going to be quite light. 3 times a day. Again, I like to highlight or underline the important stuff there. Raise your hand if you know how much food the shrimp gets a day. Molly? Still thinking? Kinley?
3/5.
Yeah, you're getting 1/5 3 times a day. So 1/5, 1/5, 1/5. 3/5? Got a label? Grams. 3/5 of a gram. Question 2. Complete the table. Okay, so how much did you get in one day? 3/5. Rylan, how do you think I get 7 days? If you get 3/5 every day. Multiply it by 7. Okay, what's 3/5 times 7? I can't cross cancel anything, so 3 times 7 divided by 5. So we could make that improper fraction into a regular fraction. What's 21 divided by 5? 4 and 1/5. Maverick, how do I get 30 days?
You take, 3/5 times 30.
3/5 times 30. See anything you can cross cancel there? Sophia? Divide by 5. Divide by 5. 6 times 3. 18. Okay, so number 2 is done. Question 3, what is the constant of proportionality? What number is next to the 1 in my chart? To the right of the 1. Molly? 3/5. What does it tell us about the situation? What does that 3/5 mean? Jonas?
How much food is eating per day?
Yeah, 2/5 of a gram of food per 1 day. Question 4, if we switched the order of the columns, so if I flip this over, what would the constant of proportionality be? So if I put all these numbers first, and I want to know what number would go next to the 1 to the right of it. Anybody have an idea?
Grams of food per day.
Say that again?
Grams of food per day.
Okay, that's what we already have. I want to know what's going to happen to this number. Read.
You're gonna get the reciprocal.
You're going to get the reciprocal. Sound familiar? Yeah, you'd be right in the other equation. So if you flip the order of the chart, you're going to get 5/3. Why? Because you use the reciprocal. All right, number 5. So this is the most important part of the lesson, guys, being able to write these equations. And again, if you can write one, you should be able to get the other. What letter does it want me to use for food in grams? So looking at number 5, what does it say to use what letter for food in grams? F. So I'm going to start with that. Whatever's in the second column comes first. F equals. Then you're going to write the constant of proportionality. What number is to the right of the 1, Lauren? Lauren, what number is right of the 1? 3/5. And now I got to write whatever letter represents number of days. What's it say it wants me to use for number of days? D. There's your equation. Okay, so once again, your steps, if you could write them down if you want. What letter does this column represent? That goes first. And you write equals. Then you look for the constant of proportionality. That goes second. And then whatever letter wants me to use for this goes last. All right, but it does say write 2 equations. Now that we have one, that should be easy. Cameron, what do we do?
Flip the letters.
Flip the letters, flip the variables. And what do I do with this guy?
Use the reciprocal.
Use the reciprocal. Now I have my 2 equations. Okay, if a tank has 10 shrimp in it, how much food do I need to add every day? So how much does 1 shrimp eat? 3/5 of a gram every day, so I got to take it times 10 shrimp. Cross cancel the 5 and the 10. 3 times 2 is 6 grams. Okay, if the aquarium manager has 300 grams of shrimp food for the 10 shrimp, how many days will it last? So you just told me I need 6 grams every day for those shrimp. I have 300 grams, so how long will those 300 grams last if they have 6 grams per day? 50 what? 50 days. 50 days. It says explain or show. I showed that I took 300 divided by 6, and that will be just fine. Okay, summary on the next page. Again, shows you the most common equation that we'll use. Y equals kx. Remember, k is a constant of proportionality. And then underneath there, it shows you how to get the other equation. You flip the letters, and you reciprocal the constant of proportionality. Okay, your assignment, starting on page 44. Okay, again, complete the table. I'll just have you help you start with this one. Again, it says write an equation for converting number of meters to kilometers. Use x for the number of meters, so once is use x for this one. And use y for the number of kilometers. Once is use y there, so that should be easy to write the equation once you get to the chart completed. Number 2, you're going to write 2 equations. One says W equals, one says B equals. Again, once you get one, the other one should be pretty easy. Tells you what letters to use with what there. All right, just kind of to look at that one, they're 28 pounds each for those concrete blocks. So how much will they weigh if I have B blocks? That should be simple. If you have 1 block, how much would it be? 2 blocks, 3 blocks, when they're 28 pounds each. So that should give you the constant and what letter to use for blocks for the first equation. Question number 3, I think you can handle. Question number 4, what is the constant of proportionality? That means what number is to the right of the 1. So go ahead and put that in your chart so you can add that. Some people will say, well, 3 is next to the 1, but remember it's what number is to the right of the 1. It doesn't give us that here, but you should be able to get that by looking at what's happening to all the other numbers. And then write an equation for it. And question number 5, again, selecting all that apply. All that applies. So those 5 questions, just those 2 pages, that'll be due tomorrow.